So it's my great privilege to introduce Dr. Srinivasan Ramani, who's the next speaker in today's colloquium. He's very familiar to the readers of the Hindu and people who have worked there like myself. He's a deputy national editor at the Hindu. He anchors explanatory journalism, data and op-ed sections of the newspaper. He has a PhD from the School of International Studies, Jawaharlal Nehru University in comparative politics and political thought. So prior to his journalistic career, which spans about 17 years in Economic and Political Weekly and the Hindu, Srini worked as a software analyst at Infosys Technologies Limited. His interests and duties in the Hindu include writing editorials on politics, international affairs, governance, public policy, and sport, anchoring the daily data journalism product Data Point, and editing the Hindu's explanatory journalism offering pages, text, and context. He is also involved in creating interactive and visual stories for the Hindu's online edition. I look forward to a very thought-provoking talk on data journalism and its applications to science. Srini, I leave the floor to you.
Am I audible? Hello? Yeah, thanks. Good morning, everyone. Thanks for the kind introduction, Shubha. So, what Shubha didn't say is that I'm not a science journalist. So, I'll put that on record first. What I'm going to do is, I won't say even that I'm a data journalist as well. I'm a journalist who uses data a lot. And myself and my colleagues in the data team in the Hindu, we have been doing so many data stories that span different areas that not just pertain to non-science fields but also science as well. So what I'll do is, I'll try to give you some examples of data journalism that we do and how that pertains to science and how we use science in non-science data stories. That would largely be what I'll be doing in this presentation. But before I get to those things, I want to set some context as to what role data journalism plays in our products and in journalism in particular. So this is something all of you journalists, who have been trained to become journalists, you must have heard in your class day in and day out. The three critical roles of a journalist today is to come up with good news dissemination, and for these three purposes. One is credible information, three roles rather. One is a credible information role, where we need to report without editorializing our opinion. All these things pertain to print media in particular. The second being working on critical investigative stories that involve deep analysis, reporting, investigation, and so on. And third, which I personally believe is also intrinsic to being a journalist, is having a role to build a certain agenda, right? And that agenda, in the case of my newspaper, I believe, is that we want to stay constitutionalist. We want to espouse progressive and liberal values. In some other papers, the emphasis will be different. Some other institutions, emphasis will be different. So this is largely the role of media today in the existing milieu, as a fourth estate. And in today's context, you will notice that apart from legacy media, you have the rise of social media, and you have more information but less gatekeeping. You have a lot of unfiltered news, lack of context. You have the rise of fake news, and there is also the fact that especially younger readers prefer to source their news not from traditional networks but from social media in particular, and they have the ability to switch on to different sources rather than fixating on one source in particular. So these are all different challenges to legacy media and media in particular. And therefore, it becomes incumbent for us that in this situation, in this milieu, we need to provide context to news and just not news alone, right? Because there is enough sources for news. What we can do as journalists is to bring context and also organize news better in order to have a more informed public, right? And that's where I believe that data journalism plays a role as well. The reason I believe data journalism plays a role in fulfilling what we just discussed is that there is something called objectivity in data. There is something called verifiability in data. Like, for example, if I come up with a data story and I mention the source and tell you that this is where I got this data from, then I'm telling the reader that if you want to verify for yourself, right, what we have done and how we have interpreted data, if you want to check it out, you can verify for yourselves, right? So there is an element of verifiability in it, and therefore that adds to credibility of the work we do, and that way we are able to set context and inform our public better. Apart from that, there is also expediency, right? Unlike just textual journalism, where we try to explain things in 1,000 words, a picture can do that better, right? And therefore, visualized stories have more appeal. We can also be economical with space, especially in print, where space is a huge space is premium, right? So for all these different purposes, data journalism plays a very important role, and also helps us build our credibility, and also establishes a certain trust with the reader because of the inbuilt verifiability aspect that is part of it, right? So just to set the context of why we do data journalism today, not just as a feature or as an add-on, but rather it has become core to what we do as journalists, right? Okay, but what does data journalism mean to us, and what I think it should mean? Data journalism is not just simply in coming up with fancy interactives, or just showing a series of charts without context, merely reporting, let's say, financial results of companies, or just there's a government press release, they throw up yada yada numbers, you just repeat it ad nauseum and just say this is what the government is claiming. That is not that I don't think is comprehensive data journalism. Comprehensive data journalism much more than that. So in our opinion, data journalism is a way of telling a story and coming up with a certain hypothesis and test that hypothesis with the data that you have, sourcing data to find out if the hypothesis holds true, and if it doesn't, then come up with alternative hypothesis. Again, look for data to test that hypothesis, and iteratively come up with enough information so that you can tell a story. And we do this data stories not for the data's sake, but but to set a narrative. That means verification or context setting, and also for comparative purposes. And we also believe that data journalism is actually not something that is something that replaces old school journalism. Like we do non-data journalism. Imagine a world where there's no data journalism, but we did the journalism the right way. What we used to go to the ground, talk to sources, look at what is going on, report, and then analyze and write, right? So we believe that data is a tool that doesn't supplant what we do, but rather enhances what we do as old school journalists. And finally, we believe that data journalism actually helps us to further the idea of research. A journalist cannot always be in the business of trying to explain why some things are happening. We can find out patterns, we can show patterns, we can show correlations. If you want causations, if you want to clearly emphasize that X is the reason for Y and Z to happen, we can't always show that. We can only show patterns. It's for research scholars and scientists to take it forward and to either prove it, disprove it, improve upon it, and so on. So I believe that data journalists can do that role of setting the context for scientists to take and work on issues further. And that, I think, is a core role of data journalists. Keeping all this in mind, so what are the different kind of stories that we do? We try to connect the seemingly unrelated things, right? Like, for example, we have data on electoral bonds, and we have data on corruption, right? So how to join those two different things, right? That's the role of a data journalist. And come up with a hypothesis first, and then based on that hypothesis, look at the data and see whether the data supports the hypothesis. If not, either negate that hypothesis and say there is no correlation, or try to find more data that come up with the alternate hypothesis and look for data and so on. Now, how do we do it? The way we do it is we first look for data sources. If data sources are available already, we either scrape the data from that using online tools, or if the data is held by government agencies, we come up with old school methods like filing RTIs, using journalists to ministry contacts and so on to get data, and then visualize that data using simple charts, explain the charts in a story with an introduction and conclusion, and then present the story with conclusions. Basically, this is what is the life cycle of a data story. We normally do not just use any data. We only use verified data, and as much as possible try to use official data sources, because we know that officials are accountable for the data. So if there are inconsistencies or if there are problems with the data, we can actually flag that as well. So we don't trust any data source that is put by anyone. So we generally use official data as much as possible. Right. So as I said, data journalism as an offering, like say 8 or 10 years ago, was more like a feature. Like we used to do this as a visual filler, in the context of print especially. Like we had a mass of text on the op-ed page, so we needed a small section which will show a graph or a chart that comes up with a finding. Let me just show you the journey of our data stories in the Hindu. Like this was the opinion page, and look at the small corner here. This was the space allocated for data point. That's how we did our data journalism 10 years ago. Slowly and steadily we noticed that we had the ability to interpret data and come up with more insights. So the space increased, and we could do, this was the kind of stories we used to do in a small section. And slowly and steadily the space got enhanced, and we were given this much space. Just a graphic with some text in it trying to explain the charts, right? Then we noticed that we needed more text to explain this graphics, and then went on. Now we have a much more space now. And now we have a full-fledged story with infographics and text. So, and this has become a daily feature now. So every day we come up with stories, and these stories can be plain routine stories that track inflation, track fuel prices and so on. But it also could be very deep investigative stories, such as investigating electoral bonds, looking at climate change patterns in a very nuanced manner, and so on. So it has now become a core offering in journalism today. It's no longer just an adjunct or a filler offering. I believe there are 6 types of data stories in terms of complexity. The first one is just simple. Okay, this is a very simple story. We just want to track, let's say, diesel prices over time. Right? This chart is very simple. We use a line chart to simply depict it. It's the first and easiest form of showing a chart. Let's take it up further, ramp it up further. Okay. Now look at this. This chart, looks at, let's say, a pattern of crop fires, right? So every winter, people in North India complain about pollution, right? And one of the key reasons for pollution is the crop fires that burn in Punjab and adjoining areas where farmers burn their crop to prepare for the next harvest season. And so what we did was we looked at satellite data to look at the number of forest fires that are happening across years and in different months, right? And it's very clear that if you look at this table, it is very clear that the numbers peak in April, October and November, right? In November and October in specific more before the harvest season. So, basically what you're trying to say is that the first peak is when Rabi crops are harvested and Kharif crops are sold. And the second peak happens in October, November, where Kharif crops are harvested and Rabi crops are sold. So simple table that will tell you that these fires happen in particular months. Then we wanted to not just limit it to the months and when these things happen. We wanted to show which are the areas where these fires happen the most. And luckily, because satellite information can be easily translated into geographical information, we took these numbers and then plotted it district-wise. So we then combined Punjab and Haryana together here and looked at district-wise crop fires. And we found out, for example, there are the specific districts, Firozpur, Fazilka, right? Yeah, they registered the highest number of crop fires and so on. But there is also a shift we looked at the average of crop fires from 2012 to 2017, and we noticed that some districts have much higher fires, But in 2018, there was a drop in the, the number of fires, because there was some method, programs implemented to reduce stubble burning, and that's the reason why you could see that there was a reduction in the number of fires. Now again, what I'm trying to say is, here we used data that is publicly available of fires that you can source from Bhuvan and other, other publicly available data sources. We used it to show time-wise, and also show it like location-wise, right? And this tells you a small story about how, when do crop fires peak, stubble burning, when does stubble burning peak, and also which are the districts they happen, and over time what has been the intensity of crop or stubble burning, right? Right. Let's move on. Now that one did not have too much conclusion. It was just patterns, looking at patterns. We could take, we can look at multiple data points and then come up with a detailed pattern analysis as well. Let's look at this story. Okay, this was a story we did in 2018 during the huge floods that happened in Kerala. Right now, typically what we do as daily newspapers. What we'll do, we'll be tracking every day the rainfall that is happening in a particular state, and we'll also track, if floods are happening. We'll also track water spills and so on. So what we wanted to do was to link all these things up, right, and show whether the catastrophe that happened in terms of the flood, was it related only to the heavy rainfall, or was it also related to man-made factors, right? So we looked at the data to show that. In order to do that, we need to look at the life cycle of how does a flood occur, right? So therefore, what we did was we looked at first rainfall data. When we looked at daily rainfall from June 1 to August 15. We also compared it with the normal average rainfall for these days based on history, right? And we could see that on August 15 there was some, there was a huge spike. There were other spikes as well in July, but in August 15 there was a huge spike. 9-fold deviation from the normal, right? Okay, now that's with respect to rainfall. So what happens when there is heavy rainfall? Obviously it means that the inflow of water to reservoirs also starts to increase, right? So we looked at inflow levels to major reservoirs. There's a Idukki reservoir, these are all rivers, right? So we wanted to look at the inflow levels across major reservoirs during the same period, right? And we could see that the inflows were peaking in some reservoirs during this very same time, during August 15, right? So once you have the inflows, what happens to the storage in the reservoirs, right? So clearly what's happening is that as rainfall peaks, the storage levels also peak. And by August 15, almost every reservoir is filled to the brim, right? And so because they are filled to the brim, and due to heavy rainfall, what happens is there are spills. So the water spills from reservoirs and flows outside, and we could track that as well over time. And then once these spill and then move on to the rivers, then we can see using flood monitoring data what are the levels of water in the rivers, right? And we took the data on August 16th or so to look at what was the flood levels in the rivers. So this story actually gave us the full life cycle of when rainfall peaked, when did the spills happen, when did the flows increase, when did the reservoirs get filled, how did the spills happen, and how did the floods happen, right? So what we could deduce here was that because of heavy rainfall, these reservoirs were filled to capacity, right? And when the peak in rain happened on August 15, because the reservoirs were already filled up, the heavy rainfall on that day resulted in very huge spills, right? So this was in 2018, right? In 2022, a very similar situation happened. I don't have the graphic here. A very similar situation happened, but there was no flooding. So we wanted to find out how did the Kerala government manage it. So we spoke to a dam engineer. He told us that unlike 2018, where the reservoir levels were maintained based on static data. Let's say IMD is saying you might have heavy rainfall, and therefore, based on that, releasing the spills. This time they use dynamic models to look into various kinds of forecasts right? And if there is a particular forecast that says that there is a possibility of heavy rain, then they release water over time. So they kept the reservoir levels. These reservoir levels, they kept it at less than 80%. Once the peak monsoon season started, right? And if it went beyond 80% after rain, they released that water, so that there was always some capacity to fill in the reservoirs. So when the days of major rainfall occurred, there was no spills. They managed to control the spills, and therefore the floods were also controlled, right? So the dam managers said that because they had dynamic ways of looking at forecast data and also reservoir levels, they were able to keep reservoir levels at such levels that spills did not occur, right? So this again, we didn't come up with any suggestions. We said this is what happened, right? But we could understand why something like this did not happen in 2022 because we did this, right? So a data journalist need not come up with solutions, right? But they can look at patterns and say, and come up with a story and say, in 2022 you did not have the same situation even though there was heavy rainfall. In 2018 you had heavy rainfall but you had floods, and you could make comparisons, right? All right, so that's pattern analysis. I'll show you some other story as well. Okay, if you remember during the Lok Sabha elections, there was this talk that turnouts were low in many places, right? The argument was that these turnouts were low because of an extraordinary extraordinarily hot summer that was being experienced in various states, right? So again, we need to test that theory, right? So how do we do it? So luckily, because IMD maintains in the meteorological department, they maintain everyday temperature data in flat files, right? And which can be accessed via Python library, right? So all I need to know is that, so this is 2024, and let's say Sikar in Rajasthan is going to elections on April 15th or April 18th, right? I need to find out on April 18th or on a similar day, were there, or approximate day, were there elections in 2019 and 2014? Because in all these election cycles, the election calendar was more or less the same, right? And look at turnouts on, turnouts in April 24, turnouts in April 29, turnouts in April 24. Temperature in April 14, April 19, April 24, and see the sigma. The difference in temperature and difference in turnout. So if there is an increase in temperature and a decrease in turnout secularly across different constituencies, then I can say that the turnout has been affected due to high temperature, right? If on the other hand there is no correlation, right? In some places temperatures have gone up but turnout has remained high. In some places temperatures has come down but turnout has has come down, and so on. If there is no correlation, then I can say that the water turnout is not because of this reason, because there is very little correlation. So we actually looked at IMD data and looked for each constituency the change in temperature, the temperature change between 14 and 19, 19 and 24, and 14 and 24, and the turnout difference also, and we did some correlations. And what we did was, we also drilled the data down a bit further. So the theory is that in urban areas, right, especially, summers feel even more hotter because we live in concretized areas, and concrete actually enhances the temperature that we experience, and experience temperature is even more, right? So we wanted to therefore divide these constituencies into tropical areas, semi-urban, urban areas, and urban areas, and see if there is a correlation in turnout and temperature change. And you notice that the correlation is very weak, right? So typically, if for good correlation you need at least 0.7 or 0.8, but we had 0.037 for tropical areas, 0.2 for 0.3, and so on. So it's very weak correlation. So we could say that there is very little correlation between turnout and temperature. At the same time, while there is weak correlation, the correlation is weakest in all tropical areas, but there is some correlation in urban areas where there is a link between higher temperature and lower turnout. So that somewhat adduces, somewhat says that our theory is somewhat right, right? But again, what we could say for sure is that it was not temperature alone that was causing lower turnout. It could be other reasons, and that's for political scientists to look into, and so on. There are other theories, like for example, some said that the turnout was low in places like Bihar and UP, and the fact that men turned out far lesser than women suggests that migration could be a factor. So men from Bihar were migrating to other places and they were not able to vote, while women could vote. So there were many theories propounded, but we could say for sure that it was not temperature that was resulting in lower voting. Okay. Again, pattern analysis. We can also do a lot of fact checks. Okay, this is not related to science, but I'll still, this is another kind of data story that we do, where we take a statement from a minister or a public figure, right, and fact check it using data. Now, this was right at the time when the special status of Jammu and Kashmir was abrogated. Now, one of the reasons the reasons that were offered by the Home Minister were that it was poor healthcare, poverty, lack of doctors, and slow economic growth. These are the reasons for their abrogating special status, right? Now, it's one thing to say that how does it matter? How does this relate to, taking out special status? But we first wanted to show if these are all true. If it is really true that healthcare is poor in Jammu and Kashmir, if it's really true that poverty is high in Jammu and Kashmir, is it really true that there are lack of doctors? Is it really true that there is slow economic growth, right? So we have to therefore fact check this, right? So how did we do it? We looked at different parameters, all provided by the government. So look at the source, RBI, Niti Aayog, National Health Profile, etc., etc. And we compared Jammu and Kashmir data across states. These dots that you see are data for each state, right? And let's take life expectancy. So the x-axis shows the age from 65 to 75, right? And notice that Jammu and Kashmir's life expectancy is 73.5, right? And 18 states had worse life expectancy compared to Jammu and Kashmir. Only two states rather had better life expectancy than Jammu and Kashmir. So clearly, you couldn't say that life expectancy is poor in Jammu and Kashmir, right? Then we looked at doctor ratio, number of people served per government doctor, right? And we noticed that only 6 states had a better ratio, right? And 23 states had a worse ratio compared to Jammu and Kashmir. So clearly, that fact is also negated. Then we looked at rural employment. Here, we could say that something was problematic. Only 9 states had a worse rural unemployment compared to Jammu and Kashmir. Poverty rate, again, only 7 states were better. Infant mortality, only 9 states were better. Per capita state GDP, only 8 states were worse. And human index, 18 states were worse. So clearly, the pattern here is that there might be 1 or 2 indices where Jammu and Kashmir was not doing particularly well. But if you take the overarching perspective, then the Home Minister's statements were clearly false. So if this was the reason to abrogate special status, then those reasons didn't hold. That's what we wanted to prove here. So again, looked at different patterns too, and the point that I wanted to say here was we did not actually parse data and then visualize. We took the data, visualized, and the visualization told the story. Okay, so sometimes you need not even interpret data. You just visualize it the right way, and it will tell you a good story, right? Okay, let me move on. This is fine, just vaccination data and so on. Okay, so again, this is some kind of a fact check. After the June 4th market crash, there was this theory that retail investors were hurt by the June 4 crash. I mean, because of exit polls, misleading people, and so on. We wanted to fact check that. Let me move on. We found that that's not true. In fact, retail investors sold their stocks more and they didn't make a profit, but at least they were able to sell their stocks, while the institutional investors, on the other hand, took a hit. Right? and so on. Okay, now as I told you, sometimes even in non-science stories, you need the imprint of science to tell a clear-cut story, right? I'll show you. Right. Okay. Okay, this is an interactive we made to interpret the 2024 election results, right? It's self-explanatory. This gives you the seat tally of the NDA, seat tally of the India bloc, and the vote shares of individual. Now, if I want to know how these different electoral coalitions performed, let's say geography-wise, right? So I have this filter here called rural, right? So if I click on rural, this will tell me, this will show the map of first who is doing, how in these constituencies. It also gives me a snapshot. It will tell me that, the NDA won 43.75%, India won 37.08%. You can compare it with 2019 and 14 as well to see whether their vote share increased in rural areas or not. But there's the important thing here. How did we decide if the certain constituency is rural, semi-rural, semi-urban or urban, right? The classification for a certain area as rural or urban is provided by the census, right? And census gives you the data at district level, broken into block levels and ward levels and so on, right? Now, electoral constituencies, right, they don't have the same contours as that of districts. So when you are seeing news channels showing you urban rural data, it's problematic because they are using district information to overlay on electoral constituency information and giving you this data, and it's inaccurate. So how do we then do it? If the boundaries are not matching, how do we do it? So what we did was we utilized a data source which actually projected light intensity data. We know for a fact that rural areas are more expansive, lower number of roads and lower number of structures, and also therefore less electrified in terms of less intensely electrified as compared to urban areas. So if I take a snapshot of a particular area from a satellite at night, right, urban areas will shine brighter, right? Rural areas won't shine brighter, right? So there are data sources that track night light intensity data over time, right? And they store it at very micro levels, very small area levels. Now if I aggregate it, I have that data. If I aggregate it and lift it to the assembly constituency level, and then aggregate it further to the Lok Sabha constituency level, and then I make a comparison. Urban areas will have very high night light intensity, semi-urban areas will have slightly lower, semi-urban will have slightly lower, urban will have the lowest light intensity, then I can make a good classification. So we did that to basically come up with population density, and using that we are able to parse electoral information of different forms. So you can parse further how was the states in Hindi heartland doing in rural areas, and it will give you a figure, and so on. So even for stories that are simply not necessarily related to science, I'm simply trying to interpret electoral results. Science helps, right? That's something I wanted to flag. Let me move on quickly. There are several stories that we have done similar to that. Like you must have seen 3 weeks back, people in Chennai, we did a story looking at polling booth data, right? And we mixed and matched it with property price data. So generally, if you ask someone, a political scientist or a psephologist, what is the category that you use to define voting patterns? They invariably say caste or community, right? They'll say some communities vote this way, some castes vote this way, and so on. But we know for a fact that in cities, in particular, class as a construct or as a variable in terms of determining voting preferences has become more prominent over time. I know for sure that in Delhi, because I did research on Delhi, for example, in Delhi that in 2014 there was a clear class divide. The poor, the urban poor and the upper middle class, a completely disparate coalition, they voted for the Aam Aadmi Party, while the lower middle class voted for the BJP, right? How was he able to do that? Basically, use same principle. The idea was basically because we know people live in areas, and for each area the municipality provides you what is called guideline values. Like for example, in Arepuram, a housemate, the guideline value for a property could be around 15,000 rupees per square feet. On the other hand, in Rayapuram or in North Chennai, some of the places where the poor live, the property prices will be much low, right? So if you triangulate different data, property price data, polling booth voting data, and polling booth location data, and draw patterns, you can come up with very interesting insights, which is what we did here. Look at this, just let's take Mylapore for example. If you look at the areas, so these are areas with low property prices, that's guideline value of 3,300 to 4,900 per square feet. And look at here, look at this. The range of vote shares that BJP was receiving in these areas was between 10 to 15%, right? Maximum in this place where they got 30%, around 15 to 30%. But the DMK was always doing better in these areas. But you move up the value chain, and if you move up the property price values, and if you look at these areas which have higher property prices, the DMK is still doing well in some areas, but the BJP is doing exceedingly well in the wealthier areas, right? So without doing a survey, but by mixing and matching different databases, we are able to come up with clear insights and correlations saying that the BJP's vote share is higher in wealthier areas, while the DMK's vote share is quite good across different areas, but particularly so in the lower income and poorer areas of Chennai, right? So this is how we basically triangulated different data sets to come up with the data story. Okay, these are all deep dives. Today's paper we did something on participation in the Olympics. I'll not belabor the point and move on. All right. Now, print gives you ability to tell a pithy and concise story using graphs, but online stories, online visualizations actually gives you exhaustive analysis. As I showed the election analysis that I showed you, that's a form of online story that we managed to do. There are some very interesting data stories. This is not by us, but by Reuters. It's a wonderful story. I encourage everyone to have a look at it. This actually looks at air quality data in Delhi over time. And look at this. It's taking a bit of time to load. Yeah. Okay, this is basically time-lapse photography that looks at PM 2.5 level from 12 in the morning to midnight, right? Why am I not able to? Oh, yeah, look at this. So it combines photography with data, right, to tell you a story that says, when does PM 2.5 values peak in a particular city, right? The New York Times also did a very interesting story. I recommend you have a look at it. They gave Raspberry Pi devices to two children, one child from an upper middle class family and one child from a lower income family. And that Raspberry device tracked PM 2.5 level in the areas where the children were, from the houses to the schools to the playgrounds they were going. And the data clearly showed that class is a problem in terms of pollution also. A richer child from a well-off family is able to live in less polluted environments, while a child from a less well-off family experiences more pollution, even though they live in the same city and probably in the very close locales, right? Because the child in a school is sitting in a room with AC, while the other child is sitting in a classroom right below a metro station. And they were able to show this using data. They just gave two devices. The devices tracked PM 2.5 level granularly over every hour, and they were able to show this data. They were able to tell a very interesting story. Right. Now that I showed you these examples, how do we do this, right? So what I wanted to emphasize was, gone is the time when you journalists had to depend upon coders, software experts to get the data out for them and then do the story. We can do this on our own now. It's not difficult at all. We have lots of tools now, and GenAI in particular has revolutionized things. I'll show you how. But quickly, so how do we do it? For scraping, you use Python scripts. There are a lot of very good Python libraries like Beautiful Soup, which does good HTML data scraping and so on. Analysis, of course, there are free tools like your Google spreadsheets, more than good enough. If you want to do more involved stuff, you can use R. And if you want to do good visualization for basic visualizations and interpretation, you can use Tableau. For mapping, again, QGIS, Tableau, and R. For data story presentation, you can use, if you want to do very solid interactives, there is something called D3.js, which is a JavaScript library which can help you code in visualization. Flourish is a very good tool. You can just plug the data in and it will give you different formats in which you want to visualize and so on. Easiest to use. Anyone can use Flourish. D3.js, something of a learning curve. I don't have time for this. Maybe some other time I can give you, a hands-on workshop on how to use these different tools. Even more so now, because of the availability of a lot of tools, we could do very involved stuff. Like for example, we did a data story on Muslim representation in Indian assemblies, right? We wanted to find out which are the assemblies where Muslim representation is high in India, and which are the assemblies where it is low. And is there a pattern over time? Has the number of Muslims representing constituencies in some assemblies increased over time, decreased over time, and so on? Now, in India, we track scheduled castes and scheduled tribes, right? So we know if a particular candidate belongs to a scheduled caste or a scheduled tribe, but religion as a category is not mentioned in electoral affidavits. So one way of doing it was, what we did was, we thought we'll use a machine learning software, right? So there is this website called babynames.com. I don't know how many people have seen it. So this site actually tells you if you want Muslim names, there's a huge list of names, right? Hindu names, huge list of names and so on. So we wrote a machine learning program that learned that this name could be a Muslim name or Hindu name by feeding the data. They're scraping the data from babynames.com, feeding to the program. So now the machine has learned that the probability of this name being a Hindu name is so much, probability of this name being a Muslim name is so much, and so on. That's ready. Then I feed the data from our assemblies, right, to the same machine learning program and ask you that if this person name is a Muslim or not. So it throws you some values. Now there could be 50-50 values also, and that you can always go to the reporter and check. Like if someone is reporting from Odisha, I can ask my colleague in Odisha, do you know this person is a Muslim or not? And he'll tell you, yeah, I'm sure. So that way you can adjust, and so that's how we were able to, do this data story, and we found that there are, almost 10%. In many states with more than 10% Muslim population, there were 0 Muslim MPs, right? And this is Muslim representation over time, and then we looked at party-wise, and then we looked for each state, right? So we look at states like Delhi, for example, didn't have any Muslim MPs since 1989. So we were able to do it for assemblies also, parliament also, so on, using machine learning software, right? All right. Yeah, as I said, GenAI, has made our job much more easier. Can I give an example? Yeah. Okay.
We also need to give some time for questions.
Okay. All right. Okay, this is a story we did today. 1 second now. Okay, we wanted to show, the basic idea was, we wanted to say that while Indians are not getting medals in large numbers in the Olympics, the participation levels have increased over time. Okay, so we wanted to show that from 2000, Sydney Olympics in 2000 to every edition since then, you look at every discipline, let's say archery, and look at the different events, men's individual, men's mixed team, etc. Over time you notice that in every event you have Indians participating. In badminton, some events you don't have participants, but others have it. In boxing, so we were able to look at this pattern event by event and so on. And we were also able to list down the events where we had no participation, right? The essence we were trying to say, the point that we were trying to make was, even though medal-wise India is still not among the elite, but our participation levels are starting to go up over time. Now, this data is available in Olympics, Olympics.com. I'll just show you. I'm not able to get the exact, okay. Okay, okay. This is the data. All disciplines, all teams, and we have for each Olympics, right? Now, I know that this record is kept in a certain fashion, right? If I click on disciplines, it will show me disciplines, and within the disciplines, I can look into teams, and within the discipline, I look into competitors, right? So all I need to do is to write a code that mimics my operations here to get the data out, right? So all I have to do is to go to GenAI, right? And this is what I tell it. I tell GenAI, look at this URL. I have 3 doc boxes whose HTML code is attached here. When I click on each of these drop boxes, I get options. Then I need to proceed to scrape these options in the following manner. I just have to tell that to GenAI in simple English, right? And once I do it, it immediately gives me a Python script, right? Now I need to test this Python script and see if it works or not. That might be some problem. So I keep iterating. I say, I did run this script, but I got this error. No, sorry, I'll show you. I did run this script, but I got this error. Yeah, this is the error. Can you check why I got this error? So then it will give me another script correcting for the error. If you keep on iterating, finally it will give me the code, right? That will generate the entire. So if I want to run this code, for example, I copy the code. Run this code, it will automatically start generating the data from each Olympics and put it in a Excel sheet. So it's starting to scrape it for each event, right? It'll take some time. I'll directly show you the full output here. I already have it ready here. So this is the data that is scraped and given by the scraper, right? It gives you for each event what is the discipline, what is the event, right? Now I just have to go and look at whether Indians have participated. That's another table, scrape it from there as well, and then mix and match it, and this is my final output, right? Sorry for rushing through, but I just wanted a glimpse of how we can do things using GenAI. It's been much easy to do that. Use ChatGPT, and you can make it work like a donkey to do things for us, which we were not able to do before because we are journalists, we are not coders, right? Anyway, move on. Yeah, let's 1 minute. I'll just
Have to
yeah.
ask questions.
Yeah. So I just finally, just to conclude, okay, again, there are pitfalls of AI use. Other speakers have already spoken about it. AI is capable of hallucination, fake news, etc., etc. So there's always got to be a human element involved. We don't use AI for news generation, for fact checking and anything. We use it like a donkey to give us code. Just to put it pithily. Then there is always the importance of human gatekeeping when you use AI. Just to conclude, data journalism has evolved now. It has become more of a legacy media product. It is not just a feature anymore. It increases credibility, informativeness. Data journalism methods remain safe for all kinds of stories. It's science journalism or nonsense journalism. And GenAI tools have made interactives and complicated IT and data journalism tasks much better and easier. That's about it. Thanks so much.
Questions? Yeah. Yeah.
Hello, sir. So you have talked about data journalism. You showed a lot of especially regarding the Kerala floods, and you showed district-wise data. But my question is that in the context of elections and especially live sports, people usually tune into TV media because it gives instant update. So the TV, especially during elections, they do provide infographics, but the time constraint is a big factor. But newspapers, you get a lot of time to interpret the data.
Absolutely.
How can we solve this in a time where people are reading very less and focusing on multimedia?
Yeah, see, gives us a business opportunity also. We are going to tell readers that if you want context, if you want to understand things better, you won't be getting it in places where news is instant, where news is, we won't have the time to set that concept. We provide it in print, and that's how we reach out to readers, right? And I feel that, I mean, I might be wrong because I'm not a market surveyor, but I know that publicly minded people do read print papers now because they want the context. You might already know that people who are preparing for civil service exams, preparing for various, who want to be public servants, who want to, or even scientists, they read print because they get context from there. And I believe that over time, while it might be boring, it might be, people might not feel the medium, attractive enough. But I think the value for the medium will enhance over time if we keep on generating contextual stories and insightful stories. And the relevance of legacy institutions will prevail over time. Yeah.
We have time for one more question. Anyone?
Is there any
Yeah.
Is there any specific tool that you use for fact checking when it comes to data journalism?
Okay, we do use tools for plagiarism checks. Like there are something called Authenticate. There's plagiarismcheck.org and so on. For fact check, we use human. We use journalists to do fact checks, and they use Google. They use Google Scholar. And of course our own archives. The advantage of being a institution that has been in the business of news for nearly 145 years is that you have a very robust archive. So we use our own archives to fact check. So yeah, and if it is if fact checks require expertise, then we reach out to experts. So yeah. Thanks.
Thank you, Srini, for that. Paliwal. Ankur Paliwal is a multi-award winning independent journalist. He writes mostly about science, inequity and queer people. He is the founder and managing editor of Queer Beat, a collaborative journalism venture focused on accurately covering LGBTQIA+ communities in India. He's also a senior producer with CNN's As Equals project, where he edits a story series called Beyond the Binary, which looks at what it means to live as a trans and non-binary person in the global south. In his 13 years of journalism career, Ankur has tried to shine light on the stories of underreported people and places. He has written about neglected crops and diseases, queer and indigenous communities, and caste and climate change from India, Ethiopia, Tanzania, Kenya, Ghana, and the US for various publications, including The Guardian, Nature, Scientific American, and 52. He has received multiple reporting fellowships from the Pulitzer Center, Doctors Without Borders, Thakur Foundation, and Nature Press Foundation. In 2021, he was a fellow at the Entrepreneurial Journalism Creators Program at the City University of New York. Ankur has a master's degree in science journalism from Columbia University in New York. And of course, what he has not mentioned in his biodata is that he's won the AAAS Kavli Science Prize, which is a gold medal for the best reporting in a certain category. So welcome to the podium.
Now I'm going to say that cliche thing that I'm standing between you and the lunch. Maybe some of you eat your lunch early, I eat my lunch early. I'll try and make the presentation interesting, exciting, so you don't fall asleep. Thank you, Shubha, for that lovely and kind introduction. We have already heard really fabulous and fascinating talks this morning. I am here to present a view from the margins and why that has been a driving force in the kind of science journalism that I have tried to do. Also, one of the goals here today is to have us a really expansive view of science. Think of science beyond what scientists do in labs. I want us to think about, which some of the earlier speakers touched on, is who gets to be in the lab. and that is what I'll be talking about today. But before I begin, I want to thank the American Association for the Advancement of Science and the Kavli Foundation for supporting my appearance here today as part of the AAAS Kavli Science Journalism Award Lecture Series. I also want to thank ACJ for inviting me here today and for giving me this opportunity and stage to talk about something I'm really passionate about. The picture that you see on the slide over there is a picture that I took about 3 years ago from a village in Maharashtra. You see those handles on the wall? I'll come to those handles later. Just remember the slide. As I'm talking about the margins, okay. So what I was talking about is that what's on the margins on science. But I'll go back a little. Historically, most of the science journalism across the world has focused on and continues to focus on big subjects tackled by big scientists, affecting big number of people or catching the fancy of big number of people. Think moon landings, green revolution, AIDS epidemic, cancer, heart diseases, climate change, and recently COVID-19. All of these subjects are really important to be covered as they are complex and keep evolving. But what tends to happen is that when newsrooms or journalists are talking about these subjects, they pay much less attention to and sometimes completely overlook the marginalized communities who are also affected by these topics. What is their view on these topics? And I want to cover some of those topics today in my talk today. Some are here. Rare and neglected diseases, something I've reported a lot about in my career. Orphan crops. Mathematics is one area I feel like should be covered more, isn't covered enough in Indian journalism. Underrepresented communities like Dalit, Indigenous, and LGBTQIA+ communities. Like I said in the beginning of my talk, I want us to think about who gets to do science in the labs. Scientific collaborations are increasing across the world. What is the nature of those collaborations? Who gets to do what in those collaborations? Who gets to participate in science? These are all the views from the margins. In other words, I'm talking about the underreported. The underreported is also the one who often gets misreported. But why do I cover the underreported? When I started my career as a science journalist, I started with Down to Earth magazine. Some of you may have heard of the magazine. It's run by Center for Science and Environment. It's a fascinating ground for journalists if you are starting out your career. Really rigorous reporting, and I'm fortunate that I got to be a part of it. When I started covering science, I just found myself gravitating toward the marginalized communities, their questions, how they were affected by the big topics that the magazine was covering. But at that time, I didn't quite know why I was doing that. But in the last couple of years, when I've tried to slow down in my journalism and asked myself why I was doing that, I found some clues, and which is where I would encourage all of you to look into your own motivations about why do you want to do journalism, what kind of specific journalism you want to do, and where you can bring in your own experience to contribute to the journalism that you want to do. I grew up in a very small town in UP. I'm gay. I did not find myself represented in the stories that I was reading in the local newspaper, in the media. I felt invisible in the stories that I was reading. So my effort has been, when I started my career, and I'm now far more intentional about it, is to make communities feel seen, because I did not feel seen earlier. So which is what I try to do now. And I'll talk about the underreported, what it means to be underreported, through some examples of the subjects that I've tried to cover and the communities that I've tried to cover. Off balance. This is the story that won the AAA's Kavli Science Journalism Award in 2022. The story is about a rare genetic disease that is there across the world, but affects a lot of people in India too. When I started researching the disease, I actually found really no mention of it in the Indian media. I could not find a news about this disease. I'll tell you a small story about covering the story and how did it come to me. In 2019, I got a call from a scientist, Mithali Mukherjee. Some of you may have heard of her. She was at the time working at the Institute of Genomics and Integrative Biology in New Delhi. I had met her a couple of months ago before the call to cover something that she was researching about called Ayurgenomics. Science, as she called it, at the intersection of Ayurveda and genomics. She had received mixed coverage in the media. There was already quite a bit of stories about her, but mostly negative. Some journalists and the media outlets had just completely mocked her because it had Ayurveda in it. When I approached Mithali, I just wanted to sort of check what kind of questions she had. What I found is that she was just beginning to scratch the surface of this thing that she wanted to research, and some of her questions were genuine, which is what I reported about in my story. Maybe it was in the way I reported the story that she called me that afternoon in late 2019, and she said that, Ankur, I want to tell you about something that she and her team had been researching for 20 years. And she said that we have fiercely guarded it from the media attention. They had fiercely guarded what they were working, which was this rare genetic disease, from the media attention because it affected some of the most vulnerable communities in India. They were also living with severe stigma because they had the disease. I'll get a little bit technical here, but I'll keep it simple. DNA. Think of DNA as a twisted ladder, just in case you don't come from a background in science, and the rungs of the ladder are made of these letters, which in science we call bases. Again, oversimplifying it here, the way these letters are arranged guides how the proteins are made in our body, and the proteins pretty much do everything from forming muscles to determining a color of your eye, the curl of your hair. I got no curls, that's a different matter. So they determine pretty much everything, but sometimes due to mutations, these letters repeat more often than they should. So what happens because of that? That then leads to formation of abnormally long chains of proteins. All of this is super fascinating if you start writing about science journalism. Abnormally long chains of protein that then accumulate in your brain. And they start affecting a specific area of your brain called cerebellum, which controls movement. So what happens to the communities who get this disease is that their movements begin to shake. I mean, for example, simple movements, everyday movements like walking, talking, holding a cup of tea, hailing a taxi, climbing a set of stairs, swallowing food. And over time, these symptoms become more and more severe. And in places like India, where we don't have strong health systems, especially around disability, the patients become bedridden, completely dependent on their families if they have family support until they die. There is no cure for the disease. It is so rare that it does not even find a mention in the list of rare diseases that the Indian government has, because all the list that the Indian government has only lists rare diseases that have a cure. This one doesn't. And there's something really tragic. I mean, it's a tragic disease, but there's something even more tragic about the disease, is that these repeats tend to get longer in successive generations. So if I get the symptoms when I'm 40, and if I have children and they get the repeat from me, they'll get a longer repeat, which means they'll get the symptoms much earlier in their life, say for example when they're 25, which is when they have just exited college, started working, and they start getting the symptoms. So a lot of the communities that I was talking to, they felt like, why did I even study? I wanted to do that. I wish I had known that, that I'm going to get the disease. I wouldn't study this thing, or I wouldn't become a dancer. Now there is more knowledge in the communities. But what happens is that because they're living with this movement disorder, and especially these communities, there's so much stigma that women especially do not even get out of the houses. Their families don't let them, because if they do, the world outside is going to find out that they have the disease, and nobody would marry them. Now that there is knowledge in the community that it exists, because there's, one thing I forgot to say is that it primarily exists in communities that practice endogamy, have historically practiced endogamy. But now there is knowledge that it's the endogamy that is causing the disease. They want to marry outside. But if the outside world, outside community, people who are outside the community get to know about this disease, they won't marry them. So they're pretty much trapped with this disease. And there is, again, no cure. This is a family I met in Saharanpur, Niyamit Ilahi on the right. She has the disease. 4 of her sons have the disease. One of them died when I was reporting about the story. This is Ashish in Buldana. Wanted to become a cricketer, but couldn't. His sister behind was working as a teacher in a school, but now she's at home. Priyanka in a village in Buldana. Another thing that I noticed while reporting the disease is that most of the time it's the mothers who are the caregivers of these children, and they're constantly worried that if they die, what will happen to their children. Their only hope, there's only single hope they have, is doctors like Mitali and Farooq, who is leading the research in New Delhi, that they will come up with a cure and they will have some sort of a solution. But Farooq has his own problems. He doesn't have funds. These are I want to come back to this picture, is that these handles I found in most of the houses I visited. Before they get to the wheelchair, they use these handles to walk in their house because their movements are challenged. This is something that Farooq said. So, because it's a neurological disorder, the field is rich, it has funds, but most of the funds tend to go to diseases like Alzheimer's and Parkinson's. And funds then determine actually how many scientists get into that field. So if the field is not rich with funds, researchers won't get in, because they want to advance in their own career, research something, write papers and advance the science. But if they know that this is not an area where there are funds, they won't get into it. So again, the field itself doesn't progress. After I reported the story, this is something that Farooq said when I asked him this question, is that it's only natural that everybody wants to play cricket, which is what everybody wants to probably do. Alzheimer's and Parkinson's research, or a heart research, or a cancer research, how many are throwing a javelin? But it's there, the javelin, we need more funds. So Farooq and Mitali are also trapped. Very quickly, some years ago I did this story, again, a neglected tropical disease I reported from Ethiopia. How I got the story, because I just asked some of the scientists who were working on the story, who were working on neglected tropical diseases, that tell me the most neglected tropical disease. And this scientist told me that go to rural Ethiopia and you'll find a fascinating disease that there is really no press about currently. This was many years ago in 2015. I traveled to rural Ethiopia, and what I found was absolutely fascinating. In rural Ethiopia, there is this culture that people walk barefoot, and the soil is toxic. So as they walk over and over, as they walk there, the toxins inside the soil get into their feet, and they lead to some sort of a chemical reaction, because of which their feet enlarge. You might have heard of a disease called elephantiasis, in which there are large feet, something like that. But the feet become really large, and the skin ruptures. Infection gets in. It looks really grotesque and ugly, but communities are living with it. When they go to the doctors there, the doctors give them medicines, but the medicine is not the cure, which is why this disease completely fell through the cracks of the global international health community. A scientist started looking at this disease, a British scientist who was traveling in Ethiopia, and she figured a simple cure, which was shoes. Because the disease is not caused by any pathogen, bacteria, a virus, which is that most of the funds, health funds go to, the shoes were the solution. If people wore shoes, they would not get the disease. And those who had gotten the disease and their feet were big, the thing that was needed is that make large shoes. When you make large shoes and clean your feet every day with just soap and water and wear shoes, your feet will slowly come back to the normal. Such a simple solution to a problem which is affecting millions of people in Africa, especially in rural Ethiopia, but it had completely fell through. The point I'm trying to make here is that ask questions from the margin. Ask questions that a lot of people are not asking. There is a lot of merit in highlighting these stories. If you don't, some of them would probably never come out. The scientist who was researching the disease told me that she got a lot of attention after the story came out. But there's a point I want to make about covering vulnerable communities. This is the big shoe that people wore there, and their feet then came back to normal. So I was trying to make a point about the vulnerable communities. Be transparent about how and how much they will be represented in the story when you are talking to them. When I was covering the rare disease story in India, I told all the people that I'm talking to you first time, this is the first interview. I may come back to you later and ask you more questions, but you may not be represented in the story. So you need to know that. And so then you can decide whether you want to be a part of it or not. This is the power dynamics question. Give them the option to refuse the interview. I think most of us don't do it, especially when we are covering vulnerable communities. When people, if you're interviewing somebody who has more power, they may tell you, actually, I don't want to get interviewed. But a lot of vulnerable communities just assume that because you have come to them, they're obliged to answer to you. But tell them that they can refuse the interview. You will find out this will actually make the interview much better. Over-explain potential harm. What do I mean by this? Again, when you're covering vulnerable communities, sometimes they're not educated. Even if they're educated, they're living in areas where they don't have access to big media outlets that they watch. So tell them that the story may feature in a big media outlet, and it will get a lot of attention, which could harm them. Or if they and the people around them don't watch that media outlet, tell them that the story can get translated. It has a way to come into the WhatsApp groups, which may then reach you or people around you. A lot of time I have found that when I explain these different kinds of scenarios which could cause them harm, they said they don't want to be named. And initially when they started, oh, no, you can name me, there is no problem. But here you really need to protect the vulnerable communities. So over-explain harm, give them all the scenarios that you can think of. Keep checking. If you have time, I mean, I do magazine writing, so I have a lot of time as the stories develop. I tell them, I keep checking with them if their life situation has changed. Should I still be naming them? Should I still be writing about them? A lot of times it has happened that when the story is just at the publication stage, people have pulled out. And I have respected that decision. My editors have respected that decision and changed the story. But keep checking with them. Another question that I have tackled a lot in my career is, who gets to do science? It's another margins question. It's a culture question, it's a social question which some of the presenters before me dealt with. And then who gets to do science and then what kinds of science gets done is connected to that. I did a story for Nature magazine in 2023 looking at the diversity data in some of the top scientific institutes in India. What I did is that for about a year, I filed lots of RTIs in these top scientific institutes, including TIFR, IITs, IISCs, asking about the data on the Dalit, indigenous, OBC scientists at different levels, professor, assistant professor, associate professor, PhD. I also looked at the higher education survey data to figure out how many actually are even entering science. And I'm not the first one to write about this story. It has been reported quite a bit, but I looked at the data extensively. Here is what I found. In some of these institutes, less than 1% professors are Dalit or Adivasi. And in some of the top science institutes, like you will see TIFR, not a single Dalit or Adivasi professor in the institute. So who is getting to do science here? The gray bars represent the scientists from the privileged community. So this is at the top level, and you'll see that representation as assistant professor is slightly more, then it reduces, and at professor level, it's much, much less. Which is also why if you read science stories in media, they're some of the least diverse stories in terms of the sources you're talking to. Because when you, as journalists, when you go to these institutes and you're asking questions about who is doing what and what is their opinion on something that's going on in the world, you're only hearing mostly from the scientists from the privileged caste. You're not hearing the view of the scientists from the less privileged community because they're just not there to give you the view. Then I looked at, so what's happening, how many are actually entering the sciences at the undergraduate level. It's the undergraduate data that I got from higher education surveys. At that time, the 2020 data was the most recently available data. You'll see that the arts graph is much higher when it comes to Dalit and Adivasi students. But do they like arts more than science? That was the question I was asking. Again, I was not the first person to ask that question. I spoke to a lot of people who might be thinking about this same problem. I spoke to Sonajaria Mins, one of the scientists. She is a famous computer scientist and Adivasi in JNU. At that time, she was the vice chancellor of Sidho Kano Murmu University in Dumka, Jharkhand, surrounded by a lot of indigenous communities. She had been asking the same question, and she had collected data for a couple of years when she became the vice chancellor, and she saw a pattern, the same one that is reflected in the higher education survey, is that most of the students who were applying for the undergrad courses were taking arts and humanities. They were not taking science. Not because arts courses were more popular, like I said, it's not that they liked arts more. What she found in her research was that the teachers and mentors specializing in science in schools were just not there in the areas the students were coming from. Or some of the teachers who were there in bigger towns would not travel to the smaller towns to teach science. So what the students studied was mostly arts and humanities. Again, the click. Or the science schools were too far, and the students needed to help their parents do the agriculture work or other things, so they could not travel too far to study science. Lack of role models within their families. They did not have scientists in their families or people who studied science or could tell them that there is this fascinating world out there you should study. Fewer people to guide in their network, or the science courses had higher fee. Because as you would know, there are practical exams. They just make the curriculum more expensive, and they just could not afford the higher fee. And these were some of the reasons which is why fewer students were entering the undergraduate courses. Another thing I found is that if people got into undergrad level, did the masters, there was a sharp decline at the PhD level. This is again the data from top IITs, mid IITs, ISCs, and BHU. 10% representation from Dalits, just 2% representation from Adivasis at the PhD level. When I spoke to these Dalit and Adivasi PhD researchers and Dalit and Adivasi professors who were working there, a pattern kind of emerged, which then I corroborated with the institutes across, in the institutes that I was collecting this data from, is that when they enter the institute, almost all of them said a version of, there is nobody like me around me. So when they were going to be taken by the supervisors, some of them would just refuse. And if there was institutional pressure on the supervisors to take the Dalit and Adivasi or Adivasi student, they would just not pay enough attention. And because of which, a lot of times students just drop out. So then I asked off the record, of course, some of these scientists from the privileged communities that why they are, why is it that you're not working with Dalit and Adivasi science students? And they said that, look, Ankur, it's not that I don't want to. I'm working in a system that privileges publishing papers, and to publish papers, I need a student who already probably comes with a good understanding of knowledge of science, can support me, we can do it faster, and that's how my career progresses. It's a bit of a generalized statement, but this is what they said, is that Dalit and Adivasi student tends to take more effort from my side. As a professor, I need to give them more time and resources. I just don't have time. And the system I work in, or the university I work in, it's not that they are giving me a promotion to work with underprivileged students. So the system is such that it's not incentivizing me to work with the students. So it's a problem both ways. Now, fortunately, this story and a lot of other stories like this that came out at that time created a lot of pressure on the science and technology institutes in India to then create systems to bring in more researchers from the Dalit and Adivasi communities, like training them, creating special quota to bring them in. And a small point about the affirmative action or reservation is here that it brings you into the system, which is really important. But if the system doesn't support you, you drop out. So then there's a second layer of protection that needs to come in here, which the institutes need to provide. This is another data point that I found. I filed lots of RTIs to the science and technology branches of the government that provide funding. You will see that most of the funding, over 80%, has gone to scientists from the privileged caste. 0.7% Adivasis, 6% Dalit, and this technology transfer division, it's a 5-year data. Again, you see who is getting to do science. People, it's not that, Dalit and Adivasi students have fascinating questions, things that they want to progress in their science, but who is getting the support? That's a question that we should be asking, and whether there's a system that's supporting that or not. When I began my talk, I said that I'll be talking about unequal scientific collaborations. These collaborations are increasing across the world, tackling some of the biggest problems like AIDS, COVID-19, climate change, heat, agriculture, pest, all these things. But if you look at the makeup of these scientific collaborations, there's a peculiar makeup. The makeup is that if the university is in the global north, US or UK, and in the global south, India, Sri Lanka, parts of Africa, the scientists in developing or least developed countries would be given the role of data collection. or talking to the communities. So they will collect the data, talk to the communities, send the data over to scientists in the global north who will analyze the data, make sense of the data, write the paper. There's massive inequalities on how the division is done in terms of who is doing what. Another important part that came out in some of the research that I have done is who has got the money. The funding institutions historically have given, and now this is changing because of more journalism on this now, the funding institution has historically given money to institutes in the global north because there is this biased understanding in the minds of funders that they have the systems, that these institutes have the systems to figure out how the research should be run, or they are able to manage the money more better or more efficiently, and those systems are not present in least developed countries. But whoever, remember this always, whoever has money decides what gets done. So the scientists in the global north then decide what is the research priority on the pest in Africa that's destroying the crops of people there. What should we study first? What kind of question we should ask first? What kind of data collection should be done first? And then that leads to all kind of inequalities in the system. Then the products that come out, a lot of them fail because of this reason, because the way it is designed, it's unequal. So the products actually don't work for the communities and they fail. It should be the other way around. Now the funders are realizing because of this pressure, and systems are being created to give money to the institute where the problem is. This is a recent paper that has just come up talking about the same problem, which continues. Quickly, who gets to participate in science? AIDS research is one of the longest running research, but even now, these are recent figures, women and girls make up only 20% of the participants. This is global data, even though they make up the majority of the people with HIV. Older people, only 7% of the trials. These are all views from the margins. When you're standing alongside communities on the margins, you will be asking these questions. So think about where are you standing, on whose behalf you're asking the questions. Continuing with my desire to make the underrepresented communities feel seen, about a year and a half ago, I started Queerbeat to cover underrepresented LGBTQ communities in the media, which are also the most misreported in the Indian media ecosystem. Because I'm a science journalist, so we also do a lot of science stories in the media outlet. Here on the left-hand side, it's a recent story that I did on the non-binary community, how that interacts with the health system there, which is very, very binary. So all the surgeons in these big top institutes, we spoke to some of the really top institutes in India who do the gender transition surgery. The understanding is mostly male to female and female to male transition. They have no understanding of non-binary communities. There's a lot of dismissal of the non-binary identity. What's happening here is that when non-binary people are going to these doctors, they have a very different desire of transition. It's not your usual male to female or female to male transition. They may be dysphoric about one particular part of their body. For example, they may just be dysphoric about their breasts. They want the rest of the body to remain the same, but just don't want the breasts. Some, because they don't fit into the male and female binary, they want a chest where there are no nipples. Now this may seem bizarre to a lot of scientists and surgeons who are in the Indian medical system, but this is not new. There's already a lot of research in the Western world. There's a lot of work that the LGBTQIA communities have done with the medical systems across the world to change curriculums, to change systems. Now there are guidelines in places that how do you work with non-binary communities to give them the care they want. It was fascinating to see some of the non-binary people in India who worked with doctors here, and we interviewed a doctor in Assam who acknowledged with a lot of humility that he didn't know this. And he said that you tell me, what do you want done and how can we do this together that affirms your identity. And what we see is that the communities are helping the doctors. They are finding the research papers, sending it to the doctor. They are finding the examples that this was a case from Japan or the US where this kind of transition was done. Look at this, how this was done. Maybe you can speak to the doctor there. So these kind of interactions are happening. This story appeared nowhere else but in Queerbeat because we understand the community. We are asking these questions from the margins. I'm ending it here. But what do these stories told from the margins do? They question system of power in science and hold them accountable. They question who gets to produce and share knowledge with the resources that they need. People have questions and they have knowledge, but they also need resources. They make as I've been saying, they make the underrepresented, whether a topic or communities, feel seen. And I can't stress this more. There is so much power in feeling seen. It just doesn't help the community, it helps people around the communities. They push a discourse to make science inclusive. So your science journalism is actually making science inclusive. Like I gave you that example of the pressure that a lot of journalists and media outlets put to ask the institutions to create systems to bring in more scientists from the Dalit and Adivasi community. So you are actually helping make science inclusive when you put these pressures. And inclusive science is just science. Thank you so much.
Any questions? Yeah, there's a.
You can hear me right or no?
Aditya.
Thank you, sir. I wanted to ask, what are the roles of both people in the center and people in the peripheries in creating this, creating sciences like and something out of experiences of all people, like not just science done by cisgendered, heterosexual, mostly male people. Because, for example, the conception of gender not as a binary but as a spectrum. So that is in the field of science as a whole, that is relatively recent because people who weren't cisgendered were not allowed to speak up for a long time. So what are the roles that which are required of what are the actions required from people both in the center and the social peripheries to achieve this type of science?
I mean, one of the things that they just have to do is collaborate more, talk to each other more. I think the talk itself is not happening. I also want to say is that people who have power need to realize that their power, that they have it, and need to leave their chair, need to leave the seat and create the space for others to come in, which is also not happening. And also there's a lot of hesitation in the marginalized communities to ask questions because then they fear that there would be consequences. So the system need to be created that it's safe for them to raise their voice. It's safe for them to ask questions and there would be no consequences. Only then we are looking at a system where everybody is asking questions. A science is getting done that helps everyone.
Can you show the name of the research again? The name
Sorry?
of the research you had mentioned, there was a recent research about collaborative experiences globally. Can you show the name of the research again?
The global collaboration I was talking about, I can just give you my slide and you can have it. Yeah. I mean, if you just Google, there are lots of papers. I mean, it's a very hot area right now, studying inequality.
So you were talking about.
Just call me Ankur.
Yeah.
I'm not used to swear.
Yeah, Ankur, so you were basically talking about stories about the marginal people, and I get it. A very important part of it is to reach the policymakers and stuff. But a lot of what people's journalism also, but more so specifically science journalism, on the margins is dealing with, let's say, a CNN or a Queerbeat, or even English press, English newspapers, whatever, they are not reachable to the people who are actually affected by those issues. So there needs to be a transfer of power, transfer of knowledge to those people, and in a medium format package which is consumable by them. So how do you do this?
Great question. This is something that in Queerbeat we talk a lot about, and to some extent at CNN. What we're trying to do is just do more collaboration. So if we have done a story in English, we try to talk to local outlets. Like we have worked a lot with Khabar Lahariya, that works in UP, translating the story so they reach the communities where these conversations need to happen more. Because we have been doing these stories, I'm just very fortunate to say that a lot of translators have come together saying that these stories are important. We want to translate these stories in Hindi and so that they reach more people. So when you start doing this work, the support also come your way, and I've been very fortunate.
Ankur, I have a question. You mentioned that in the earlier slides that it's important to reach out to people as voices of expertise who are not the canonical people that you reach out to and so on. But then how do you find out? Because there's a lot of reluctance, especially if you take caste, there's a lot of reluctance on the part of the scientists to own up to their caste and say that I am from this community. And very highly politicized people do it, but not so much scientists. And how do you transcend this problem?
Great question again, and something I have struggled with a lot. What I do is I send mass emails. I send lots of emails. If I'm covering mathematics department or physics department, I send the email to everyone saying that, look, I'm working on this story. These are the people I want to talk to. If you are one or know someone who may talk to me, just connect me. And that way, I've got some help. But it is hard because the systems are not safe for people to come out. But I just reach out to lots of people.
Thank you.
Yeah, one last question, okay?
I'm Mayank. I wanted your views on the rise of sensationalism and specifically in science journalism, because this is a broader topic, but we had seen it in the tech industry with Boeing and now emerging into the health and medicine aspect of science journalism. So what do you think of the reporters and journalists moving into certain innovation reporting rather than into the whistleblowing business of science journalism?
I'm sorry, I didn't get your question. You're asking that
the rise of sensationalism in science journalism,
reporting.
because journalists are, rather than going for the reporting on innovation, they're going into the whistleblowing business.
Oh, I understand what you're saying. I don't have a fully formed answer to this question, I'm sorry, but I would just say that work with your editor, the newsroom, to create systems where this kind of journalism is discouraged and you're asking the right questions. There are checks that are put in place so that these kind of stories, you're basically checking that whether it's a sensationalist story or it's an accurate representation of what's happening in the world. To me, it's more of a checks and balances questions if you're working in the system.
So thank you very much, Ankur. I mean, really, really very, very sensitive.